Welcome back, everyone. Thank you for not leaving us. We're going away. All right. So our speaker is Christopher Chan. He recently graduated with his PhD degree in computer science, right? He'll be, so the title of his speech is IEDs, yeah, and neutralization. He's got presents for us here, as I can see. Robots, drones, or drill, yeah. Yes, Christopher.
Okay.
Yeah.
Great.
Thank you, Christopher.
There we go. Okay, hello everyone. Thank you for attending my presentation. I am part of NCART lab in Ryerson University. That's in the engineering building. And the work I do is urban search and rescue. And specifically, I work in improvised explosive devices and its neutralization processes. So I work with public safety. So that means Ontario Provincial Police, Durham Regional Police. And there's been some incidents with improvised explosive devices, and I think you guys may have seen that on the news, and I'll go over that. But basically what we do is we apply technologies. We're very practical, so our whole field of study in the background is computer science, and then we apply computational theoretical applications to aid in improving urban search and rescue technologies. So some things like UAVs. So UAVs, you may not think it's maybe just like a hobby, it's activity, you just fly it around, you have fun, you take pictures. But there's actually a good practical use to it. We can actually take urban disaster views like this. So we can fly over urban disaster and take three-dimensional footage and stitch them together to make a 3D model. Another thing is we can make robots to go into archaeology and to discover tunnels in Egypt. So in Egypt there are looted tombs that are too dangerous for human entry. So we build robots, purpose-built robots, and we actually bring them to Egypt, and they help drive through these holes and these tunnels that is unsafe for entry, and they will scan and map the area. So if you guys can pass this around, that'd be great. Here, this is actually a Hexacopter Uav. So you want to be able to buy this. These are more commercial drones, and they're meant for heavy payloads. So the more spins you have, the more rotors you have, the more weight it can carry. But there's also a trade-off. This demands a lot of power. So the more power you demand, the heavier the battery it is, and the heavier the battery it is, the shorter the lifetime, shorter the flight time, and the less payload. So yes, please pass it around. And we also do canine augmentation technology. So even till now, when urban disasters happen, so say 9/11, there was a lot of rubble that collapsed on top of each other. So buildings collapsed on top of each other, and there's people trapped in buildings. So they always send in search dogs. No matter how good your robot is, dogs are able to traverse through the rubble, traverse through uneven terrain a lot faster than this is a fake dog. So a lot faster than robots. And so let's give you a difference. It's cost $30,000 to train one dog, but for one robot it costs over $100,000. And when the robot flips over, and that's it. Someone needs to go in and repair the robot or retrieve it. But the dog is very mobile, very dexterous. So let's go on to my main presentation, which is on improvised explosive devices. And I'll show you guys something really cool. Okay, so this is improvised explosive devices. And today I brought in more show and tell. This is the subject of my research. It is improvised explosive. But don't worry guys, this is all inert. It's all inert. Inert means it's fake. You can pass it around. I meant this to show everyone. Very good. Very. So, and inside the improvised explosive device are explosives, and these are also inert. So you guys want to pass these around? Make sure you give it back to me. And also, touching these will leave traces of explosive traces on your hand. So you guys should wash them off if you plan to go to the airport. They will trigger an automatic explosive detector, and you may have to explain yourself. Okay. So, what are improvised explosive devices? And I'll just go over it. Improvised explosive devices are composed of unknown elements. They range in form, size, and power. And I showed you some examples right now of an example of an IED. And assemblies like these can be small and simple, like pipe bombs, or large and sophisticated things causing massive damage. So I brought in some example inert explosives, and it's what I used to research. And these explosives are built by a U.S. company that gives an exact replica of the actual explosive in terms of its atomic value, and when you go through a CT scanner or any of those airport scanners, these explosives will look exactly the same as the real ones. So they're good for training purposes, and I only use them for training purposes. Okay, so what's the threat of IEDs? Have you guys seen the news of Mississauga? There was an incident of two men going into a restaurant and releasing a IED, and it injured 15 people. So this is an IED incident, an improvised explosive device incident. And it can either be intentional or accidental. It can happen anywhere. It can cause serious injury to people and serious damage to property. So there's a huge research area in it, and it's a very open problem because there's no standardized device. So there's also a Chernobyl accident in Ukraine, 1986. There's also an Oklahoma City bombing in 1995. And there's also a Boston Marathon bombing in 2013. And in the Boston Marathon bombing, they used a pressure cooker, which is a store-bought rice cooker or pressure cooker, and they just loaded it with shrapnel. There's a Marine Corps race pipe bomb, and then there's a Manhattan dumpster bomb. So I shouldn't go over these ones, but sure, why not? So this is a footage of a Boston bombing at the moment of the blast. Yeah, something like this unfortunately can happen even in places where you don't suspect it happening.
Oh, there were people, Kirshner. That's really sad.
I saw that one guy right there.
No, yeah, we have a splash
It looks like he ran.
from the building next to the Try your dog.
So it's really important for me to figure out technologies to help police officers and first responders how to neutralize these improvised devices effectively, efficiently, and safer for both sides. So this is, people that deal with IEDs are called explosive disposal units, also known as EDU. And they use a method of neutralization called a disruptor cannon, which is on the right. A disruptor cannon is a high-powered water cannon, and all it does is it shoots a really high-powered water projectile at about 700 meters per second. It pierces through hard surfaces like suitcases, and its intention is to disperse all the elements inside simultaneously, and it's supposed to neutralize it. But what are the challenges to neutralization? There's backsplatter. When you neutralize something, it can disperse in the direction that may be harmful for people and property. There may be collateral damage, and there's safety for proximate people in EDU. And what do EDU have at their disposal? They have bomb suits. You may have seen these things. These things weigh a ton. They reduce your visibility and mobility, and they're also not guaranteed to protect you from an explosion. So what do EDU do when they do encounter an IED? They have to safely neutralize the IED by identifying the key components of interest. They can't just aim the neutralization cannon at the IED and hope for the best. It's not a blunderbuss kind of thing. It's like a sharp, precise water cannon. So what do they have? They have an X-ray scanning technology, which includes an X-ray scanner, and an X-ray backplate, an X-ray viewer, and an X-ray backplate feeder. So these are subject to a lot of limitations. You have to manually tune the penetration pulses. You have to have proper positioning of the backplate. You have to constantly replace the film or the bulb. It's disproportionate because it's a 2D projected image, and there's a lot of occlusions. You don't know what's in front or what's in back, or because it's 2D. So what do they look for in an IED? They have to look for a main explosive charge. So something like that. A method of detonation, which can be like a pager or a timer. A power source, it can be a battery, and possibly shrapnel. So here's a clip of some successful neutralizations. And these are the results of how strong the neutralization can be. So this is me at ProParms, which is the neutralization company in Montreal. We're testing the disruptor on mock IEDs I made in the lab, and we're directing the disruptor cannon at critical components for neutralization. So what technologies do I build to improve their processes? I first use CT scanning technology. I improve their X-ray by doing multiple X-ray scans, which is essentially CT scanning. It takes slices of it, and with all these slices together, I can make a 3D model with the data. And then with the 3D model, this is where I apply the computational theoretical applications. I clean up the model by removing artifacts. I have to automatically determine which components are of interest. I have to segment it. And these are all, can be all done automatically and can be implemented in the field eventually to help aid the neutralization processes. So my job, I'm not trying to replace their neutralization methods. I'm trying to augment their methods by giving them additional information. And for a lot of my work is on simulations. So you guys talked about serious games before. I actually, for my IED simulation, I made a serious game which trains EDU personnel in a safe manner. And it trains them on where are these specific components, what is neutralization. It gives them a score, a feedback. And if they do neutralize it, the game is successful. If they don't neutralize it, it's unsuccessful. So here is some reasoning we can use. We can use the reasoning from the game for. We can use it for EDU neutralization training. We can archive all the IED incidents and apply machine learning techniques to see what are the possible IEDs in the future. We can do EDU planning in distant futures. And obviously we can use IED precise targeting from the game-based reasoning. And that's really important. So suppose we encounter an IED. We use my technology to scan the IED, go back to a safe location, and determine where the critical components are. So instead of using an X-ray backplate, we use the CT scanner, scan the IED, find the critical components, and the game reasoning will tell it exactly, oh, you have to shoot it at this point, at this angle, and at this distance. So who are the people that are interested in my work? It's urban search and rescue or in CBRNE response teams. There's Ontario Provincial Police, there's Durham Regional Police, there's Sunnybrook Hospital, and I'm affiliated with NSERC, Create Addersim at, actually this is at York, and I'm affiliated with Probe Arms. And in my, this is the last slide, but in my PhD work, I did high fidelity simulation algorithm capable of modeling spatial impact points as a result of a successful neutralization of an improvised explosive device. So that's a lot for just saying I analyzed the splatter based on an IED neutralization, and it will determine where the splatter is on the wall and to approximate people. This also is, I also developed a technology to determine the range of explosive in there. So suppose there's like a variation of the TNT cast booster. Using my scanning technology and my algorithm, I was able to determine the range of the possible explosive that may be in the IED, something that hasn't been implemented yet in airport and security systems. So yeah, thank you. This is my practical work in university that applies all my years of study and work onto improving public safety processes. Thank you very much.
So, do you have any questions for Christopher?
So the Canine augmented technology, the dog can easily get to the victim. So suppose like a dog got to the victim, but the dog can't do anything but bark, right? So we have an automatic bark, and it releases. It can be supplies, a mesh router. It can be a communication device. Either way, the dog is able to communicate, is able to release something. This is called CAT technology. It's funny. It's called Canine Augmented Technology, and all it does is it releases a package. We found out the funniest thing is we found out the best improvement we made to the dog is to add flashlights, because the dog uses its nose 90% of the time. But when we added flashlights to illuminate its way, it improved his searching ability by tenfold. So we can also add in, we tried adding in 360-degree cameras, and then wherever the dog went, we used some algorithms to stitch together a model of where the dog traversed. So when the first responder has to go through the same path, we will know exactly where it goes.
Thank you, Christopher, for all your effort and help for keeping our society safe and secure. Yeah, thank you very much.